Hi, this is David. Welcome to a video review from Michael Miller's Mathematics and Statistics for Financial Risk Management. And this is a video review of his Chapter 7, Hypothesis Testing and Confidence Intervals. And so if you're here looking at this chapter, I would hope and assume that you have some familiarity with the previously assigned chapters from Miller, because this is the final chapter in a long sequence that's assigned to topic 2 in the FRM. And so Michael Miller's books, or these chapters from the books, constitute the essential statistics domain in the FRM. So we want to be familiar with chapter 2, that was basic, that was probabilities. Chapter 3 was basic statistics. Chapter 4 was common distributions in the FRM and risk. Chapter 6 was Bayesian analysis. And here we are, Chapter 7, hypothesis testing, which actually presumes, has as a prerequisite, we could say, chapters 2 and 3 at least in Miller. So I would go back and be familiar with those before tackling Chapter 7. But I'm fond of the Chapter 7, which is short on the face of it, but in fact pulls together some of these basic statistics ideas into applications. So here are the learning objectives that GARP has defined. And I'll just note that the majority of these are highly testable, especially these first two. We've seen these in every practice exam, or at least one example of these in every practice exam in recent years, and also in the historical body of published exam questions, which lags several years at least, but I can say with high confidence, pun intended, that these are highly testable learning objectives here, especially at the start. Calculate the sample mean, sample variance, and construct a confidence interval. Then we have a couple here that are really foundational in statistics, not just to the FRM, but statistics in general, and common also to other financial exams like the CFA. We definitely want to be able to define the null hypothesis and its alternative, and then the one-tailed and two-tailed tests, or the ability to conduct a one- and two-tailed test. And we're going to talk about that and its relevance to VAR back testing, and what we would assume on the exam. And we know that every year we get quite a few customer questions about this one versus two-tailed test. So I'll talk about that. And then interpretation here, finally. This is interesting because Miller's included it in the chapter, and GARP has a learning objective about back testing VAR. So I'll introduce you to back testing VAR if you haven't seen that before. And I hope I'll include a motivation here, and that is that back testing VAR is formally introduced really in Part 2, Topic 5, which of course is market risk, where it is a full reading assigned from Jorian. So high relevance there, and an introduction into what is really more deeply a Part 2 topic. Although by the time we finished Miller, we would understand enough statistics to understand really almost all of the Part 2 assignments, frankly. So there's a lot of correlation there. And so if we start with the first learning objective, calculate and interpret the sample mean and sample variance. Okay, sample mean should be straightforward. We just want to sum the observations and divide by the number of observations. Nothing fancy there. The only thing I might note is that, as usual in finance, especially in the FRM, where we have an anthology of different instructors, the notation is going to vary. So again, I would insert this caveat that let's not get too assigned to the notation, because there's at least one other author currently in the syllabus that would denote the sample mean with an X as the variable and a horizontal bar above it. I actually forget what that's called, but that would also denote sample mean. So we just want to be flexible. And then the sample variance here, we covered this before and comes up quite a bit. But notice here we've got S squared, and sometimes you could see that as capital S squared. I've noted before, though, that our Greek numbers in general denote population parameters, while Greek letters, while Roman letters tend to connote sample statistics. That's population parameters versus sample statistics. For that reason, personally, I'm not really crazy about Miller's choice here, but I'm not sure that this is his deep science. So he's used a mu. He's used a caret in the case of the to indicate the sample statistic there, the sample mean. I think the sticking with the Roman is a little better, but in any case, the sample variance here, of course, S squared, and this is the estimator, right, of the population parameter, which is familiar to us as sigma squared, right? Greek for the population parameter, Roman for the sample statistic.